We found the volume of a triangular prism and a rectangular prism in our previous session. In today's session, we will find the volume of other types of prisms, trapezoidal prisms, and prisms that have polygons as their base. Before we start finding the volume of a trapezoidal prism, let's remember with each other how to find the area of a trapezoid. To find the area of a trapezoid, the area is equal to base 1 plus base 2, this means 6 plus 8, multiplied by the height of a trapezoid, and that's 4, all divided by 2. So the area of this trapezoid is equal to 6 plus 8 is 14, multiplied by 4, all divided by 2. The answer will be 28. We don't forget that each area has a unit. Here the unit is not clear, so we simply write it's a unit, whatever the unit used, to the power of 2. Let's find the volume of a given prism. As you can see here that this prism is a trapezoidal prism. So step number 1 is identifying the type of the prism that we have. So trapezoidal prism. From the name trapezoidal prism, it helps us identify what's the type of, or actually the shape of our base. Our base is trapezoid. Now, step number 3 is finding the area of the base. We agreed that we're going to use the symbol B, capital or uppercase B. It is equal to the area of a trapezoid. As you can see here, let's identify the dimensions of this trapezoid. This is the trapezoid over here. One of the bases is 5 centimeters. We need the other base is 2, because remember that this trapezoid and the upper trapezoids are both equal to each other, so they are of equal dimensions. Let's continue. We need the height for sure. The height over here is 3 centimeters, similar to the upper one. So the height is 3 centimeters. Those dimensions are enough for us to find the area of this trapezoid. As we said in the first part, that the area of a trapezoid is the bigger base, which is 5, added to the smaller base, which is 2, multiplied by the height of the trapezoid, which is a 3, all divided by 2. And that's a 7 times the 3, all divided by 2. That's a 21 divided by 2, which is 10.5. We don't forget the unit, which is centimeters to the power of 2. Now, step number 4 is identifying the height of the whole three-dimensional figure, and that is how long is your, or how high is your three-dimensional figure. Here the height of this figure is 6 centimeters. This means that h is equal to 6 centimeters. Now remember, as I told you before, please place this value and the area of the base all in boxes in order to use them for our last step number 5, which is identifying the volume of the three-dimensional figure. We agreed that the volume is the area of the base, symbolized by capital B, multiplied by the height of the whole three-dimensional figure, and that's a 10.5 multiplied by a 6. The answer is 63 centimeters to the power of 3. Another question, find the volume of the given prism. As you can see here, this prism is also a trapezoidal prism because the shape of the base is a trapezoid. Now, from the name trapezoidal prism, step number 2, which is the shape of the base, and that's a trapezoid. Let's highlight the base over here, which is a trapezoid. Let's identify the dimensions that are needed to find the area of this trapezoid. As you can see here, one of the bases is 6. The other base is 4 because both the trapezoids here are equal to each other. So the other trapezoid is of another base, which is 4. And the height is 4 as well. Let's start our calculation of the area of the base. Third is the area of the trapezoid or the base, capital B, is equal to the bigger base, 6, plus the smaller base, 4, multiplied by the height of the trapezoid, 4 as well, all divided by 2. And that's equal to 10 multiplied by 4 divided by 2. The answer is 40 divided by 2, and that's 20 feet to the power of 2. Let's highlight this value to be used later on in our final calculations. Now let's identify the height of the whole figure, of the whole three-dimensional shape. It's 9 feet, so the height is 9 feet. This takes us to step number 5, which is identifying the volume or finding the volume of the three-dimensional figure. Capital V is equal to capital B multiplied by H, and that's 20 multiplied by 9 gives a value of 180 feet to the power of 3. Now we will be moving to other types of prisms that have a base of a polygon. Before discussing how to find their volume, let's find the area of a pentagon, for example. You already discussed with your teachers how to find the area of any polygon, whether it's a pentagon, hexagon, octagon. Let's recall with each other the rule. The area of any polygon is equal to the epithem, which is 42 here, so the epithem symbolized by A, multiplied by the perimeter of this polygon, all divided by 2. Remember, the perimeter is the length of all the sides in a polygon. For example, here we have a pentagon. Each side in this pentagon is 52. And how many sides do we have? We have 5 sides. So it's 52 multiplied by 5 equals 260 feet. To find the area, the epithem, which is 42, multiplied by the perimeter of this pentagon, is equal to 260, calculated earlier, all divided by 2 to give us an answer of 5,460 feet to the power of 2. Now the question will be, find the volume of this prism. Step number 1 is identifying the shape of this prism. This is a pentagonal prism because we have 5 sides in the polygon, so pentagonal prism. Now from the pentagonal prism, we know now from the name that the base is of a shape of a pentagon. So step number 2, we have a pentagon. Step number 3 would be identifying the area of this pentagon, so capital B. Let's highlight this pentagon and identify its dimensions. Over here, this is the pentagon that we need to find its area to help us find the volume. As you can see here, the epithem is given to us, which is 8 feet, and we have 12 feet for the length of each side. So all the dimensions are given. We can find the area of this base. It is the epithem, which is 8, multiplied by the perimeter. We agreed that the perimeter is the length of one side multiplied by how many sides do we have? And here we have 5 sides, so it is 12 multiplied by 5, all divided by 2. The answer would be 8 times 60 divided by 2 equals 480 over 2. Then the area of the base is 240 feet to the power of 2. We highlight this value. Then we move to step number 3, identifying the height of all the figure, which is 22 feet. Then h is equal to 22 feet. This value should be highlighted as well. This takes us to step number 5, identifying the volume. So V, capital V, is equal to capital B multiplied by H. That's a 240 multiplied by 22 to give us an answer of 5,280, the unit of course, feet to the power of 3. Let's take another example. As you can see here, this is a hexagonal prism because the base is a hexagon, so hexagonal prism. As you know that a hexagon has 6 sides. So the base is a hexagon. Let's highlight the base here and identify its dimensions. As you know that for any polygon to identify its area, we need to know the value of the epithem. And here the epithem is 6.1 centimeters. And we need also the length of the side. As you know that both hexagons are of equal dimensions, then the length of the sides in a hexagon is 7 centimeters. Now we can move to finding step number 3, which is the area of the base. It's equal to, as we agreed, it is the epithem, 6.1, multiplied by the perimeter of this hexagon, which is the length of one side, 7, multiplied by the number of sides. We have 6 sides, all divided by 2. That's a 6.1 multiplied by 42, all divided by 2. The area of the base would be 256.2 divided by 2, which gives a value of 128.1 centimeters to the power of 2. Let's highlight this value and move to step number 4, where we need to identify the height of all the figure, which is 14 centimeters. Then step number 4, h is equal to 14 centimeters. We highlight this value as well. We reach to step number 5, the volume of the whole figure, which is 128.1 multiplied by 14, and gives a value of 1,793.4 centimeters to the power of 3.